Today, in the next 20 minutes or so, I'm gonna give you some disease updates about soybean cyst, sudden death syndrome, and some exciting updates on white mold, application technology mostly. And if there's a little time, I'll show you a little bit of charcoal rot. We'll just play that by ear. So let's start with soybean cyst nematode. And so this is a pathogen that's been moving through the state. Many of you have probably heard me talk about this. What you're looking at here on this first frame is a nodule, a nice big pink nodule on a root, and the little lateral root by that root with the nodule is covered with these white female worms. And so these white cream colored structures are all soybean cyst. So a little information here before we get into where it's at and what we're doing about it. Just for your background, it is the top yield limiting pest in soybeans. So most of the estimates are between $1 billion and $1.5 billion lost every year in the US. And North Dakota is a part of that, and it's expanding. It's a parasitic worm that infects soybean and dry bean. Soybean is the primary host, but it'll also do some damage on dry beans. It is invasive and it's still actively expanding, and it's soil-borne. So the way this thing moves around is by anything that moves soil, whether that's soil on equipment, floodwater, snert storms, whatever it is that can move soil can move SCN. Now it's favored by high pH and dry conditions. It really likes it dry and droughty. So we had some high SCN levels last year. One important thing about soybean cyst to keep sight of is that you don't have above ground symptoms until you have some pretty significant yield loss. Usually 15 to 30% is what's thrown around before the plants actually start to turn yellow. Okay, so soybean cyst was introduced in the US in the 50s, and in the next 7 decades or so, it's expanded to pretty much every place that's growing soybeans in the US. Those spots in the south and the east are the Ozark Mountains and the Appalachian Mountains. This has really just followed the crop. This is the known counties infected since 2020, and North Dakota has got quite a number, same with northern Minnesota. And you can even see 4 areas in Manitoba that now have soybean cyst nematode. So one of the things that we want to do is keep track of where this is in North Dakota. And the way we do that is we have a soil sampling program, and we're looking at egg levels. And this is supported by the North Dakota Soybean Council. So just for context, let me show you what egg levels look like on beans before we get into the maps. So this is a good illustration of what those egg levels can do, what SCN can do, and we're using pinto beans in this. So remember that soybeans and dry beans are susceptible. So this was an experiment that was done a long time ago, maybe 15 years ago. It holds true today. There's 3 pots that you're looking at. The center one is a control, so there's no SCN in this pot. Beans look nice, healthy. The one on the left has got 5,000 eggs per 100 cc's of soil. So that 5,000 egg level is kind of a low level positive, medium level positive. And that pinto doesn't look so hot anymore. And then on the right, you have 10,000 eggs per 100 cc's. And that bean is struggling. And so just keep those numbers in mind as we go through this. So the Soybean Council sampling program has been supported since 2013. And about 5,000 samples have been submitted by growers. And the way this works is that a grower can go to a county extension office, pick up some pre-marked sample bags, take some soil samples, send them to the lab, and they get their results in the mail. And then we just get the geospatial points and egg levels to create a map. I don't see any more information than that. It's just to map it, and it's like a low res map like this one. So we'll go through what we found, and we're gonna do it by egg level. So this map has all the zeros. So about 2/3 of the samples, maybe almost 3/4 some years, are negative. And that's really good. So there's a lot of samples coming in, majority are negative. This next shape are these gray boxes, and that is an egg level of 50 to 200. That would be considered a very low level. Now I would recommend and suggest that these gray boxes, well, some are positive, some are going to be false positive. There's lots of nematode eggs in the soil. They're hard to tell apart, in fact, impossible in many cases. So if you see it, low level like this, I would recommend just sampling again. I would call it inconclusive. But then we get into some colored shapes here, and these I would consider all positive. And you can see a lot of these low level positives, 200 to 2,000, scattered about the southeast and east central part of the state. You can see a reasonable number in the Devil's Lake area and even a couple out west. These blue circles are 2,000 to 10,000. So think about that pinto bean that had 5,000 eggs. So this is kind of where you're at. These yellow, they're 10 to 20,000, and then 20,000 and better are represented in red. And those are extremely high levels. Think about that 10,000 eggs in that pinto. It's a greenhouse experiment, so it's a little artificial, but you get the idea that SCN at that level is really high. So let's look at this without the negatives. So here you have just the colored shapes, and you've got those gray kind of inconclusive areas. Certainly some are real and certainly some are false positive. And you can see that SCN, it's moving around. It's not just in Richland and Cass County. It's starting to spread pretty significantly. We did a little heat mapping, so a little bit more high resolution density mapping, to try to illustrate the point that there's a lot of SCN in the southeast and maybe into the east central and Grand Forks County. Now, just because something's red or orange does not necessarily mean every field in that area has SCN. That's not the way it works. It's really spotty. There's certainly fields in Richland and Cass that don't have it. But I would take a look at this and think, yeah, if you're in these areas, you're probably greater risk for SCN than if you're not. Okay, so what are the symptoms of soybean cyst? The most common symptom is this: beautiful, healthy field. Looks great, right? Well, this field has SCN. In fact, I'm facing away from a variety trial a few years back. I'm about 200 feet away from it, and that had a really hot zone of SCN. When you get high yield loss, it's starting to look like this. So you have these yellow patches that just show up. They're just not thrifty, kind of chlorotic, but there's nothing here that screams SCN. This is an image that Guiping Yan, NDSU's nematologist, took a couple of years ago of a kidney field, and this is on the Minnesota side of the river, but it illustrates the point that it can do some damage on dry edibles. Okay, so I'm going to leave you with a resource here, and we'll talk just a bit about management. I put a QR code on this resource. This is the SCN Coalition. The SCN Coalition is a partnership of private companies, universities, and the Soybean Checkoff. And this whole thing was formed to try to deal with the SCN situation. In the I-states, there's a lot of issues with SCN overcoming resistance. Here we have maybe a little bit of that, but the bigger thing is that it's moving around and we want folks to detect it. Okay, so if you go to this homepage where the QR code was, and I'll put that back up in a minute, the newest project that the coalition put together was a video collection called Let's Talk Toads. And there's almost 30 different videos. They're in multiple states. And I would recommend that if you want to bone up on SCN, take a look at these 2 to 3 minute videos, and you can answer most of the questions you have. For example, the one that's featured right now is how does weather impact SCN? So I would encourage you to take a look at that. So with SCN, we would recommend 4 things. The first is to test your fields to know your numbers. And there's 2 reasons to do that. Certainly if you're in the northern part of the state or out west, you're probably looking just to detect it, just to see if you've got it. And a soil test is really the best way to do that. And there's lots of information online about how to do that. What I would recommend is you take a soil probe and you go to the area where you're most likely to see SCN. So SCN is going to come in on moving soil. So field entrance would be a good place. Floodwater, along shelter belts, if the wind is blowing and soil is moving. So that would be the mission of detecting it north and west. But if you know you've got SCN, you still want to be able to sample for it. And the reason you do this is you want to see if your management tools are working. So you put in a resistant soybean, and if your egg levels skyrocket, well, you have a problem with that bean. So it's probably time to switch. So the other 3 things are to rotate the resistant varieties, rotate to non-host crops. So remember, anything except dry beans is a non-host. We got a lot of options. Probably the worst thing to do is soybean on soybean if you have high levels of SCN. And then lastly, there's a bunch of nematicide seed treatments that are emerging, and that might be something you want to consider depending on what your situation is. And again, that QR code will take you to the scncoalition.com. There's a lot more information about SCN. So one of the reasons that we're concerned about SCN is it makes other diseases worse. Not all of them, but sudden death syndrome is one of the primary ones. Brown stem rot also, but we're not talking about brown stem rot today, but we got that in the state too. But there's been a lot of questions about sudden death syndrome, and for good reason. So a little background on sudden death. This was first found in North Dakota in 2018. was found in Richland County. It's caused by a fungal pathogen. This is a Fusarium. So it's in the same genus, but it's not really related to like scab, Fusarium head blight, that sort of thing. I mean, they're related pathogens, but they don't go back and forth, right? It's a soil-borne pathogen, so it essentially moves the same way SCN does. If you're moving soil around, you can move this pathogen around. It causes a root disease. So it's really a root rot pathogen, but what makes it unique is it produces a plant toxin, and the toxin is what kills the soybean. Now, to get sudden death, you need wet springs. You need a little water after planting. You need it warm, relatively warm. And then if you rain a bit in August, periodically, it'll make it a lot worse. And it is intimately tied to SCN. And in areas where they have both, and they have good levels of both, it'll take a lot of yield. It's considered always the top 5 yield threat in the north central states in the US. We first found this and confirmed it in Richland County. It was probably there for a few years prior, but the confirmation for it to get built up in the field and for us to do our lab work took a little bit. So confirmed in 2018, not really a surprise. That's really high SCN levels, close to Minnesota, South Dakota. We know they got sudden death syndrome. In 2020, we confirmed it in Cavalier, and that was a surprise. And that was a very unfortunate surprise. You know, it moves any way soil moves, and so it can move around. And I'm going to overlay this map where the known occurrences, or at least presumed occurrences of SCN positives are in these counties. So what I would suggest to everyone is that most of you will not have sudden death. Very few of you probably will, but it's something that you probably want to take a look at while you're in your beans. If you see these symptoms, it's worth investigating further. Now, over time, we'll have a lot more sudden death in the state, but right now it's kind of rare. So the biggest thing is to keep your eyes open. Okay, a little bit about that before I show you some pictures, because this will help you think about the pathogen and what we need to help you with identification. So this is a life cycle or a disease cycle of how this thing works. So it's a fungal pathogen in the soil, and it interacts with soybean cyst nematode. You got SCN, you're going to have worse sudden death. So you get early season infection like a root rot. You get a little bit of rain on that crop, the pathogen's there, it'll infect it, create a root rot. And then it grows in the roots. But unusually, this only grows in the roots. That's kind of unusual in a lot of these different pathogens. It never leaves the roots. What it does instead is it produces a toxin that'll kill the soybean plant. So the pathogen lives in the roots and sends this toxin up, and it starts to go through the stem into the petioles, and then it creates these kind of wicked leaf symptoms that eventually will kill the plant. But this is really important for us. So if you have what you think is sudden death, we have to have the roots. So if you're going to bring it into the lab or send it somewhere, you got to bring the roots. You can bring the whole plant, but if we don't have the roots, we can't confirm it. We can't identify it. There's other things that cause those leaf symptoms. And once you get them, the symptoms will develop, and eventually the leaves will drop. Okay, so let's look at some of these. So this is the earliest symptom that you'll see with sudden death, and usually you won't see this until mid-August or so. It takes time for that pathogen to grow in the roots and produce that toxin and send it up. So I think of mid-August as the optimal time when you're going to start to see symptoms. So the first symptoms, if you see them, are these bright yellow like spots that only occur between the veins. You're not going to see these cross the veins ever. It's not a pathogen, it's the result of that toxin. Now, pretty quickly, those yellow spots between the veins are going to turn brown and necrotic. And you're going to have nice, clean veins. A little bit longer, you're going to see the leaves look like this, where you have these nice green veins, and pretty much nothing else is green anymore. And this is that classic sudden death look. Now with sudden death, the leaves will drop. So by the time you get to something like this, the leaves are going to be falling all over the place. And you're going to have all these empty petioles sticking up above the canopy. This is something that's helpful to differentiate it from something like charcoal rot, which leaves all the leaves on. So sudden death, there's massive leaf drop. And then you get a big spot of it, and this is what it's going to look like. So this is in Richland County. We took this photo here in 2020. This area is just smoked with sudden death. And the biggest thing here is that lots of things can kill soybeans, but it's really important, especially if you got SCN, to get in there and take a look for those symptoms. If If you see those leaf symptoms, split that lower stem and look for some browning on the white cortical tissue, the tissue on the outside of the stem. Okay, a little bit about managing sudden death. The first thing is we want to look for it. The second thing is we want to manage soybean cyst nematode because they're synergistic, they act together. Resistance, if available, that's unclear in the maturity groups to me. I'm not so sure how much we've got. And then there's seed treatments that are becoming available. And that link down there will take you to a YouTube video. Okay, I'm going to give you one resource here. So again, I'm throwing a QR code so it's easier to get to. This is called the Crop Protection Network. The Crop Protection Network is a group of pathologists across the Midwest and then the Mid-South, and we get together and we have our own little clearinghouse website here. And I'm one of the people that contributes, although I'll be the first to tell you that I contribute a lot less than some of the folks from Iowa and Indiana, and so you're going to benefit from what they got. So anyways, you go to the homepage here, you can look up corn, soybeans, small grains. They've got publication, webinars, CCA quizzes, all kinds of things. And there's lots of different things you can search for with soybeans. And they have a lot of information about sudden death, scouting for it information, seed treatment, foliar fungicide impacts. There's a lot of good resources here if you want to learn a bit more about sudden death. Okay, I'll touch on white mold here. So white mold, we all know, very common yield limiting disease. It's all broadleaf crops and many weeds are susceptible to the same fungal pathogen, the Sclerotinia sclerotiorum. It survives as a sclerotia, so it'll survive a long time. And it's favored by cool and wet weather. And that is important. We've not been cool and wet, but the sclerotia will survive longer than the drought we've had. The updates I want to give you are the optimization work on fungicides that Michael Wunsch has been talking about. And he's been doing a great job here. And there's lots of different things. We're just going to touch on a few things and then I'll tell you where to get more. Okay, so how this pathogen works, I'm holding a bunch of shriveled seed and these black sclerotia. They maybe survive 5 to 10 years in the soil. So even if we were dry for a couple of years, it turns cool and wet, we're going to be at risk for white mold. They survive in the soil, and when it's wet in the spring, they'll produce these apothecia, these small little mushrooms, and they kick out spores. And the spores then will infect the plant. But the way they do that is they need flower tissue. So this is an illustration. This is the same mechanism, but it's a sunflower leaf and a sunflower floret, where you can see what happened is the spore would land on that floret, start to digest it. And if it's cool and wet, it'll just digest it very quickly, and then it'll go directly right into the healthy green tissue. And that's why we spray at early flower. Of course, you know the rest of the story, right? Stems are bleached, you get more sclerotia, white fuzzy growth. I've been asked about plant-to-plant spread. Yes, that certainly can happen. When we put down a fungicide, we're trying to manage the initial infection, not the latter. But this is an illustration, again, using sunflower, where a leaf of a neighboring plant touched an infection on a stem of another plant, and it grew right into it. So once it gets established, it's almost impossible to stop. And then, of course, this is how we often see it when we've got problems, and this is not a good thing. Okay, some fungicide research updates. So Michael Wunsch at Carrington I can't tell you enough how good of impressive of a job he's doing. And he's doing lots of different things on droplet size, timing, and many more. I'm just going to share a couple updates from him quickly. The first thing is he's been looking at the impact of spray droplet size, and he's been using T-jets and Wilger nozzles. So I'm going to just go through this very quickly, and then I'll talk about the summary. So this is an example of what you'll see if you go to his website. So in this experiment, he's looking at the yield change, okay? And he's looking at 4 different levels of canopy closure. So in this red box on the top, you can see that the average is less than 75% canopy closure at R2, okay? And you go across the top, you can see the canopy gets more and more and more closed. And by the time you're on the right, it's 100% closed at the time of spray. Within the red box, he's looking at fine droplets on the left, medium in the middle, and coarse on the right. So he's testing in the canopy that's less than 75% closed, the effect of fine, medium, and coarse droplets. Now, all that data in the middle, are the blue circles, are the yield change. So the higher they are, the more yield gain. And the blue bar is the average, the median, okay? So you can see that here, there's a little bit more yield with the fine droplets. It's statistically the same. Coarse droplets a little less, but it's all statistically the same. Okay, let's move this forward then. So with fine, numerically, fine droplets are best when the canopy is at that 75% closure or less. Okay, makes sense, good coverage, right? But as the canopy becomes more and more closed, or more of the canopy gets closer to closure, the droplet size most effective increases. So in this 80 to 89%, medium droplets will give you a higher yield, a statistically higher yield. By the time you're in the 90% range of canopy closure, you're bumping up maybe to 7 bushels difference. So there's a 3 bushel difference between fine, medium, and coarse. And then again, when you're completely closed, you want to use coarse droplets for sure. So what's happening here is your coverage is really nice when it's dusty fine droplets, but when that canopy gets close to closure, you got to be able to push those droplets through the canopy to get control. And so he's showing that your droplets will, the size of your droplets, your nozzles, everything will change to optimize that application. All right, so with the T-Jets, what he's found is that you want to use coarse droplets if you're in that 90 to 100% average canopy closure. But medium will probably be better for you if you're 80 to 90%. And that's a pretty significant difference. He did the same thing with Wilgers, which I'm not going to show you just because of time, but the results are similar. Although with Wilgers, you want to use very coarse droplets when you get close to canopy or at closure, and then just coarse droplets when it's more open. Okay, the last thing about white mold I'll share with you is that timing is being optimized in many of these crops. Soybeans is one of them. And fungicides should be applied as soon as 100% of the plants reach the R2 growth stage unless the canopy closes earlier. So optimally, if the canopy is closed in that mid to late R1, you want to pull the trigger then. But if it's not, you want to wait till R2. And you don't want to wait till R3. By that time, you're going to miss the window. So timing is important, and coverage, the droplet sizes, the nozzles, that's all important too. Okay, so to access more of his updates and more of his information, you can go to that Carrington Plant Pathology webpage. Michael is actively putting up all these different presentations. So be patient, they're coming, but you can take a look at what he's got there, and he's got a lot of really good information about soybeans and many other crops. I mean, primarily on white mold, and he's doing just a fabulous job.